But a new discovery here in Texas is threatening to rewrite the entire story.
They believe they may have discovered the oldest civilization in North America.
Ancient artifacts found in central Texas. They are said to belong.
When you think of Texas, what comes to mind? Maybe wide open spaces, cowboy hats, bustling cities like Houston or Dallas, perhaps the heat or the Friday night lights. It's an image built on history, culture, and a certain undeniable swagger. But what if that image is incomplete? What if the ground beneath those iconic boots holds secrets far older, stranger, and sometimes more unsettling than we've been led to believe? Scientists digging deeper than ever before are uncovering evidence that challenges our perception of Texas. Forget the stereotypes for a moment. We're talking about discoveries that rewrite geological time, reveal hidden worlds, and hint at forces shaping the state in ways most people never consider. This isn't fiction. This is the Texas that science is revealing. The Texas we see today, arid plains in the west, humid forests in the east, rolling hills in the center, is just a snapshot in deep time. For vast stretches of Earth's history, this landmass was something entirely different. Scientific exploration, particularly the unearthing of fossils, provides irrefutable proof. During the Cretaceous period, roughly 145 to 66 million years ago, much of Texas lay submerged beneath a warm, shallow body of water known as the Western Interior Seaway. This wasn't just a coastal flood, it was a different world, teeming with life that would seem utterly alien now. Imagine not cattle but giant marine reptiles dominating the landscape, or rather seascape. Paleontologists have unearthed spectacular remains. In the rocks around Austin, Dallas, and Waco, fossils of mosasaurs have been found, enormous predatory lizards, some reaching lengths of 50 feet, essentially the T-Rexes of the ancient oceans. Alongside them swam plesiosaurs, long-necked reptiles gliding through the water, and giant sea turtles like archelon the size of a small car. The skies above weren't patrolled by hawks but by pterosaurs, flying reptiles with impressive wingspans, and lurking in the coastal swamps and river mouths. Giant crocodiles like Dinosuchus, reaching lengths easily exceeding 30 feet, capable of ambushing dinosaurs that strayed too close to the water's edge. Dinosaur Valley State Park near Glen Rose famously preserves footprints of sauropods and theropods walking along the muddy edge of this ancient sea, a tangible link to this lost era. The sheer abundance of ammonites, coiled, shelled relatives of modern squid, found throughout central Texas further paints a picture of this prolific marine environment. But the transformations didn't stop there. After the seas receded and the age of dinosaurs ended, Texas became home to a different cast of giants during the Cenozoic era. The Waco Mammoth National Monument protects the incredible discovery of a nursery herd of Columbian mammoths that perished in a single event, likely a flash flood tens of thousands of years ago. These weren't the woolly mammoths of the ice ages further north, but massive relatives adapted to warmer climes. Elsewhere, scientists have found remains of glyptodonts, essentially giant armadillos the size of a Volkswagen Beetle, lumbering across the plains alongside saber-toothed cats, giant ground sloths, and ancient horses. These discoveries aren't just curiosities, they fundamentally reshape our understanding of Texas's natural history. The familiar landscapes we drive through were once submerged under tropical seas or stalked by megafauna that dwarf modern wildlife. It's a constant reminder etched in stone that the Texas we know is profoundly different from the Texas that was. But the remnants of ancient life aren't just found baked into the surface rock. An entirely different world lies hidden, quite literally right beneath the feet of millions of Texans, holding its own unique secrets and forms of life. While the surface of Texas boasts impressive scale, some of its most astounding geological features and unique ecosystems are hidden from view deep underground. We're talking about a subterranean realm sculpted by water over millennia, vast cave systems, and the lifeblood aquifer they are intrinsically linked to. Central Texas, in particular, sits atop what's known as karst topography. This landscape is formed by the dissolution of soluble rocks like limestone by slightly acidic water. Over immense periods, this process carves out intricate networks of underground passages, sinkholes, and caverns. Some of these are famous tourist destinations like natural bridge caverns near San Antonio or Cave Without a Name near Bourne. Stepping inside is like entering another dimension. Towering stalagmites rise from the floor, meeting intricate stalactites dripping from the ceiling, formed molecule by molecule as mineral-rich water evaporates. Delicate formations like flowstones, draperies, and soda straws adorn chambers that echo with the sound of dripping water. But these caves are more than just geological wonders. They are unique biological laboratories. Deep within these perpetually dark, stable environments, life has adapted in extraordinary ways. Scientists studying these caves have discovered troglobites, species found only in caves, that have lost their pigmentation and eyesight over generations of evolution in complete darkness. The Texas blind salamander Eurycea rathbuni, found only in the Edwards Aquifer Fez pits near San Marcos, is a prime example. A ghostly, translucent creature perfectly adapted to its subterranean home. Similar adaptations are seen in certain species of blind catfish, spiders, and insects unique to specific Texas cave systems. These caves are intimately connected to something even larger and more critical, the Edwards Aquifer. This vast underground layer of porous water-bearing limestone stretches across a significant portion of central Texas, providing drinking water for millions of people in cities like San Antonio and Austin, and feeding iconic springs like Barton Springs and Comal Springs. It's not an underground lake in the conventional sense, but rather a complex network of interconnected pores, cracks, and conduits within the rock, holding an immense volume of water. Scientists are continually working to understand its intricate plumbing, how water enters the aquifer, recharge zones, how it flows underground, and how long it stays there. Mapping its full extent and understanding its complex hydrogeology is crucial, especially as demands on its resources grow and its ecosystems face threats from pollution and overuse. This hidden world beneath our feet, composed of stunning caverns and the vital aquifer, represents a critical, fragile, and largely unseen aspect of Texas's reality, a stark contrast to the sun-baked surface image. It's a reminder that some of the state's most important features are invisible. While this hidden world carved by water remains relatively stable underground, the very ground above it, especially along the coast, is proving through scientific measurement to be anything but static, constantly shifting and changing shape. The image of Texas often includes its extensive coastline along the Gulf of Mexico, beaches, barrier islands, bays, and estuaries. But scientific monitoring reveals this coastline isn't a fixed line on a map. It's a dynamic, constantly changing interface between land and sea, subject to powerful natural forces and, increasingly, human influence. One of the most significant phenomena scientists are tracking is subsidence, the gradual sinking or settling of the land surface. This is particularly pronounced in the Houston-Galveston region. Decades of extensive groundwater and oil and gas withdrawal have caused the underground clay layers to compact, leading to a measurable drop in land elevation. Parts of the area have sunk by as much as 10 feet or more over the last century. This isn't just an abstract geological process. It has real-world consequences, increasing vulnerability to flooding, altering drainage patterns, and exacerbating the effects of storm surges during hurricanes. Scientific monitoring using GPS, satellite radar, INSAR, and tide gauges precisely measures these changes, providing crucial data for urban planning and coastal management. Compounding the issue of subsidence is coastal erosion. The natural processes of wave action, currents, and storms constantly reshape the shoreline, nibbling away at beaches and cliffs. Scientists studying Texas's coast document significant erosion rates in many areas, particularly along unprotected stretches of barrier islands like Galveston Island and Matagorda Island. These islands act as natural buffers, absorbing storm energy and protecting the mainland, but they are vulnerable systems. Major hurricanes can drastically alter their shape overnight, carving new inlets or washing away entire sections of beach. Coupled with global sea level rise, which is demonstrably occurring and impacting the Gulf Coast, the long-term viability of some coastal areas is a serious concern being actively studied by oceanographers and coastal geologists. The rate of sea level rise observed at Texas tide gauges is consistent with global trends, adding another layer of pressure to the subsiding and eroding coastline. Furthermore, underwater exploration using advanced sonar and remote sensing technologies occasionally reveals surprising features offshore. While not strictly land, discoveries like brine pools, super salty, dense underwater lakes on the seafloor with their own unique chemosynthetic ecosystems, or the uncovering of previously unknown shipwrecks preserved in the Gulf's sediments, add to the picture of a dynamic and complex coastal margin. These scientific findings paint a picture of the Texas coast not as a permanent fixture, but as a zone in constant flux, actively being reshaped by geological forces, water dynamics, and climate change, a far cry from a static line on a map. The shifting land tells a geological story, but the artifacts buried within that land, unearthed through careful scientific excavation, reveal an equally surprising human story, one potentially much older and more complex than many realize. The conventional story of human history in Texas often begins with Native American tribes encountered by European explorers, or perhaps pushes back slightly to the Clovis culture, long considered the first widespread human presence in the Americas around 13,000 years ago. However, ongoing archaeological science in Texas is challenging these timelines and revealing a much deeper, more complex human past. Discoveries at specific sites are forcing a re-evaluation of when people first arrived and how they lived. Perhaps the most paradigm-shifting evidence comes from the Galt archaeological site in central Texas. Decades of meticulous excavation have unearthed a staggering number of artifacts, millions in fact. Crucially, beneath the layers containing familiar Clovis spear points, archaeologists discovered distinct tool technologies dating back significantly earlier, potentially as far back as 16,000 to 20,000 years ago. These pre-Clovis artifacts, including unique projectile points and cutting tools, provide compelling evidence that humans inhabited Texas long before the Clovis people were thought to have arrived. This doesn't just rewrite Texas history, it contributes to a fundamental shift in understanding the peopling of the entire American continent. Scientific dating methods like optically stimulated luminescence, OSL, applied to the sediments surrounding the artifacts are key to establishing these earlier dates. Beyond just pushing back timelines, archaeological science reveals the sophistication and adaptability of these ancient Texans. Analysis of stone tools indicates mastery of flint knapping techniques and knowledge of quarry sources, sometimes hundreds of miles away, suggesting established travel routes or trade networks. Discoveries at sites like Bonfire Shelter in West Texas show evidence of repeated, coordinated bison jumps dating back over 12,000 years, demonstrating complex hunting strategies and social organization. The intricate rock art found in places like Seminole Canyon or Hueco Tanks offers glimpses into the symbolic and ceremonial lives of people who lived thousands of years ago, depicting hunts, human figures, and abstract designs whose exact meanings are still debated by researchers. Furthermore, analysis of animal bones and plant remains found at ancient campsites. Paleoethnobotany and zooarchaeology allows scientists to reconstruct past diets and understand how people adapted to changing environments over millennia, from the cooler, wetter conditions of the late Pleistocene to the development of desert cultures in West Texas. These scientific investigations piece together a narrative far richer and deeper than simplified historical accounts, revealing millennia of human ingenuity, adaptation, and presence etched into the Texas landscape long before recorded history. While ancient humans left their mark through tools and art, the Earth itself occasionally reminds modern Texans through subtle tremors detected by sensitive instruments that the ground isn't always as geologically quiet as it seems. Texas is generally perceived as a geologically stable region, far removed from the dramatic earthquake activity associated with places like California. The common understanding is one of solid ground, unlikely to shake. However, scientific monitoring reveals a more nuanced picture. Texas does experience earthquakes, and while most are minor, their occurrence and distribution provide important insights into the state's underlying geology and, more recently, the potential impacts of human activity. The state is crisscrossed by numerous fault lines, remnants of ancient geological activity. The most prominent is the Balcones Fault Zone, a complex system of faults stretching roughly from Dallas southward through Austin and San Antonio towards Del Rio. This zone marks a significant geological transition between the coastal plains and the Edwards Plateau. While major movement along these faults occurred millions of years ago, creating the distinctive escarpment visible today, minor adjustments can still happen. Seismographs, sensitive instruments that detect ground motion, operated by institutions like the Bureau of Economic Geology at UT Austin, TexNet Seismic Monitoring Program, routinely records small earthquakes across the state, including some associated with the Balcones system and other known faults in West Texas, like those near Valentine, which experienced moderate earthquakes in the 20th century. These naturally occurring quakes, though usually too small to be felt, confirm that Texas is not entirely geologically inert. In recent decades, however, scientific attention has increasingly focused on a different type of seismic activity: induced seismicity. This refers to earthquakes potentially triggered by human activities, primarily related to oil and gas operations. Specifically, the disposal of vast quantities of wastewater, a byproduct of oil and gas extraction, particularly fracking, by injecting it deep underground into porous rock formations, has been scientifically linked to increased earthquake frequency in certain areas. Peer-reviewed studies have shown strong correlations between the location and timing of wastewater injection wells and clusters of earthquakes, particularly in areas of North Texas like the Dallas-Fort Worth area and parts of West Texas, regions with historically low natural seismicity. The injected fluids can increase pore pressure within basement rocks, potentially lubricating existing, critically stressed faults and causing them to slip. While the vast majority of these induced quakes are small, some have been large enough to be felt and cause minor damage, raising public concern and prompting regulatory changes. It's crucial to understand this isn't about fracking itself directly causing earthquakes, but rather the associated practice of deep wastewater disposal. Ongoing scientific research continues to investigate the precise mechanisms, risks, and mitigation strategies associated with induced seismicity, revealing that the ground beneath Texas, especially in certain areas, may be more reactive to human intervention than previously assumed. It's not just the Earth itself that holds surprises revealed by scientific study. The living things inhabiting Texas, both native and newcomers, are also revealing unexpected adaptations and posing new, sometimes alarming challenges. The wildlife of Texas is iconic: armadillos, longhorns, though technically cattle, rattlesnakes, but biological science is constantly uncovering more about the state's fauna and flora, revealing surprising adaptations, discovering rare species hidden in plain sight, and documenting the profound, sometimes terrifying impact of non-native invaders. The sheer biodiversity of Texas, owing to its size and range of habitats from deserts to swamps to prairies, means there's always more to learn. Scientists continue to find species uniquely adapted to specific Texas environments. We already mentioned the Texas blind salamander in the Edwards Aquifer, but there are others, like certain species of pupfish found only in isolated desert springs in West Texas, clinging to existence in tiny, fragile habitats. Research into seemingly common animals also reveals surprises. For example, studies on the Texas horned lizard, horny toad, investigate its unique defense mechanisms, including the ability to squirt blood from its eyes and the specific dietary needs, primarily harvester ants, that make it vulnerable to habitat changes and pesticide use. Genetic studies are also refining our understanding of species distribution and relationships, sometimes revealing that populations thought to be one species are actually distinct, highlighting hidden layers of biodiversity. The discovery or rediscovery of rare plants, insects, or even small mammals continues, often in overlooked ecological niches, emphasizing how much we still don't know about the state's native inhabitants. However, a significant and often alarming part of the modern Texas biological story involves invasive species. These are non-native organisms whose introduction causes ecological or economic harm. Scientific monitoring tracks their spread and impact, and the findings are often stark. Feral hogs are perhaps the most infamous example. Descendants of domestic pigs brought by early settlers and escaped Eurasian wild boars, their populations have exploded. Scientists estimate millions roam the state, causing hundreds of millions of dollars in agricultural damage annually, destroying habitats, polluting waterways, and potentially spreading disease. They are incredibly adaptable and prolific breeders, making control efforts extremely challenging. Another major concern tracked by biologists is the spread of aquatic invasive species. Zebra mussels, tiny mollusks that reproduce rapidly, encrust and clog water intake pipes, boat motors, and dam infrastructure, costing millions in maintenance and impacting native mussel populations. Invasive plants like giant salvinia and hydrilla form dense mats on lakes and rivers, choking out native vegetation, impeding navigation and altering water quality. Biological surveys and modeling help predict their spread and inform management strategies, but the battle against these invaders highlights how dramatically Texas ecosystems are being reshaped, often in detrimental ways, by life forms that don't belong. A terrifying ecological reality revealed through careful scientific observation. And just as invasive species can bring unexpected disruption that science helps us understand, the very weather patterns Texas is known for, particularly its heat, are showing signs of scientifically documented extremes and variations that go beyond simple stereotypes. Texas weather is often summed up with one word: hot. And while long, scorching summers are certainly a reality, a deeper scientific look at the state's meteorology and climatology reveals a much more complex and volatile picture prone to dramatic extremes that defy simple categorization. Recent events and long-term data analysis show Texas experiencing weather surprises that challenge assumptions. The most jarring recent example was the February 2021 deep freeze. While Texas certainly experiences cold snaps, the severity and duration of that event, which saw temperatures plummet across the entire state, coupled with widespread power outages, was extraordinary. Meteorological analysis pointed to a specific atmospheric setup. A severely weakened polar vortex allowed frigid Arctic air to plunge much farther south than usual. While a single event isn't proof of climate change on its own, climatologists study whether the frequency or intensity of such disruptions to typical weather patterns might be linked to broader changes in Arctic warming and jet stream behavior. It was a stark, scientifically documented reminder that Texas weather isn't solely defined by heat. It's vulnerable to extreme cold events with potentially devastating consequences. Beyond temperature swings, scientists also study other forms of extreme weather. While Texas sits at the southern edge of the traditional tornado alley, it experiences numerous tornadoes each year. Research investigates potential shifts in tornado frequency or geographical distribution, examining whether patterns are changing over time. Furthermore, Texas is exceptionally prone to extreme rainfall and flooding events, often associated with tropical storms and hurricanes making landfall from the Gulf of Mexico, but also from stalled frontal systems. Hurricane Harvey in 2017 provided a devastating case study, with rainfall totals exceeding 60 inches in some locations near Houston, shattering records. Climate scientists analyze these events, studying how factors like warmer sea surface temperatures, providing more moisture, and potentially slower-moving storms, allowing more time for rain, might contribute to the intensity of such rainfall extremes, linking local weather disasters to larger climate system dynamics. Paleoclimatology, the study of past climates using evidence like tree rings, lake sediments, and cave formations, reveals that Texas has also experienced prolonged and severe droughts throughout its history, sometimes lasting for decades, megadroughts. Understanding these past climate cycles provides crucial context for current drought conditions and future water resource planning. So, the scientific picture of Texas weather isn't just about enduring summer heat, it's about understanding the complex interplay of atmospheric patterns, geological influences, and potentially long-term climate trends that can produce startling extremes, from record freezes and catastrophic floods to intense droughts, making it a far more dynamic and challenging environment than often portrayed.